So this video is about exponential application with growth and decay. The first things you guys have to know are the equations. So if it's growth, it is going to be this equation. F of t equals P1 plus R to the t. So growth is going to be plus, and if it's decay, it's going to be minus. So F of t equals P1 plus, 1 minus, 1 minus R to the t. So the P is going to be what's called the principal. Or you can think about it as your starting amount. The T is going to stand for time. And the F of T, which is right here, you can also think about that as A equals, sometimes it says A equals, and that's your ending amount. The R is your rate, but you have to write it as a decimal. So a lot of times you're going to have to convert a percent to a decimal. So let's go ahead and try example number 1. So it says a new TV costs $1,200. The value of the TV decreases by 21% each year. Write an exponential model equation given the TV's value f of t after t years. So the first thing is this 1,200, that's your starting amount, so that's going to be the letter P. It's decreasing, so decreasing means we're going to use the minus, and 21% per year is going to be your R value. And we're going to have to write that as a percent. So in your calculator, turn it on, go to the home screen. So I'm dealing with 21% right here. So I'm going to type in 21. And then right above this parenthesis is a percent sign. So you're going, because it's green, you have to click second first, and then this parenthesis, and it comes up as 21%. Then you're going to press enter, and it's going to make it into a decimal. So let me do that again for you. So 21, second, and then this button right here, this parenthesis, percent, enter. So it gives you 0.21. So that's the number we're going to use when we plug in for R. So let's go ahead and use this equation. So f of t equals P, we have, it's right here. It's our starting amount, 1,200. Parenthesis, 1 minus our percent, we had to make to a decimal, 0.21 raised to the t. So that was the original equation. Now it says estimate the value of the TV after 5 years. So 5 is going to go in for our exponent t. So f of 5 equals 1,200 times 1 minus 0.21 raised to the 5th power. So we're going to stick this into our calculator. So clear out what's there. 1,200 times 1 minus 0.21 parenthesis. And remember, to get to an exponent, you're using this key right here. It's called a caret key, 5. So it's approximately $369.25. So it has to be 25 because if you look at the third number, it makes the 4 a 5. So that's our final answer for example number 1. Let's try example number 2. So it says, in 1990, the tuition at a private college was $15,000. During the next 9 years, the tuition increased by 7.2% each year. Write the exponential function to model this situation. So I need P, that's my starting amount. So right here is P, $15,000. It's increasing, which tells us we're going to use the plus equation. and 7.2 is the R. But remember, we have to make that into a percent. So I'm just going to go ahead and use my calculator and make that into a percent right now so I don't have to deal about it later. 6.2, second, parenthesis, enter. 0.072. So this time, though, it's increasing. So because it's increasing, I'm not going to use the minus like I did above. I'm going to use the plus. So the equation I'm using is P times 1 plus R to the T. So I have, let's see. So my start is 15,000. That's P. 1 plus the decimal we just figured out, raised to the T. And that's the final amount equal. So you can use A or F of T. So what's the tuition in 2010? So this one takes a little bit more math because our original is in 1990. So we're looking from time from 1990 to 2010. So to figure out our time, we're going to take 2010 and subtract 1990, which is 20 years. You probably could figure that out without actually doing the subtraction, but just that's how you figure it out. So now I'm going to plug in this 20 into my equation. So I have 15,000 times 1 plus 0.072, and it's not T anymore. We know T is 20. And then we're going to stick that into our calculator. Sorry, guys. So when I type that in, I get $60,254. 6254.15. If it wanted you to round to a whole number, you would just take the 15 off because it would round down. So it'd just be 6254. Okay, I want you guys to go ahead and try number 3 on your own. Write the equation, and then after you write the equation, go ahead and unpause this video so you can check it, and then we'll do part 2. So your equation should have looked like this: 23,000 times 1 minus 0.032 to the x power. I know it's minus because it's saying they're becoming extinct. Extinct means they're dying off. So the next part says, what will the population be after 13 years? So you're going to plug 13 in for the letter X. So you should have 23,000, 1 minus 0.032 to the 13th power, and go ahead and type that into your calculator and see what you get. So I got 15,069 approximately. So this is equal to 15,069. So I'm not keeping this decimal on here because they're insects, you can't round up for an insect. You have to just truncate. So just 15,069 insects. Okay, so on the back, we're going to skip this part that says using your table function on your calculator. We're going to skip that. And we're going to move down here where it says finding growth and decay rates and the factor. So let's see if I can get that to show up a lot better. It's kind of small. There we go. In the following exponential growth model, determine the growth rate and the growth factor. So think about it first as you had the 25,000 as your start amount, and you had 1 plus some number to give you 1.22. So what we're going to do to figure this out is you're going to do 1.22 minus 1.00, that's the 1, and that gives you 0.22. So 0.22, if I add that to 1, That's what gives me the base of 1.22. So right here where it says growth rate, that is what you're going to use. That's what you add and subtracted. That's your R from the front side. So we have 0.22, but you're always given it as a percent, so we need to change that to a percent. So in your calculator, if you put 0.22, and before we used this parenthesis because it had the percent sign, but if you look to the right parenthesis, it has arrow percent. So you're going to press second, the right parenthesis, and it has a little arrow to percentage, changing it to a percent, and it tells you it's 22%. So my growth rate is 22%. Your growth factor is your base. So my base is always attached to the exponent. So my growth factor is 1.22. Okay, similarly, we are going to try one with a decay rate and a decay factor. So 1 minus some number has to give me 0.81. So let's do 1 minus 0.81 and see what that gives us. So that gives me 0.19. So if I do 1 minus 0.19, it should give me 0.81. 1 minus 0.19, 0.81. So the decay rate, remember you're using your R, but I have to change 0.19 to a percent. So again, in my calculator, I'm going to put 0.19 second. Is it showing up? Yep. So if you're ever unsure, it says second right up in the top. And then I'm going to use that right parenthesis, enter, 19%. And my decay factor is the 0.81. So go ahead on your own. I want you guys to try this down here. It wants you to figure out if it's growth or decay, what the growth and decay factor is. So remember, the factor is the base. Oh, you can't see that. The factor is the base. The rate is the part we figured out right here. That's what you were adding or subtracting to get to it. So go ahead and try these 3 problems on your own. And then I want you to go on Canvas and check your answers.